In this lecture, we're going to talk about exponents and learn how to evaluate exponents. Let's start off with an example. Maybe 2 times 2 times 2 equals 8. Okay? What I basically want to do is write 2 times 2 times 2 in shorthand. And the way we do that in mathematics is we say 2 to the third power equals 8. Okay? This represents 2 times itself 3 times. All right? So a little bit of notation here. The 2 in this case is going to be known as the base, and the 3 is our exponent. Now the big mistake that a lot of beginning mathematicians make is that they say 2 times 3. That's not the way we read this. We read this as 2 cubed, which is 2 times 2 times 2. Okay? For example, let's look at 4 to the third power. Well, notice our base is 4 and our exponent is 3. 4 to the third power means 4 times 4 times 4. Okay? 4 times 4 is 16. 16 times 4 is 64. So 4 cubed, another way to write that or read it, is 64. Example or two. How about negative 3 to the fourth power? Well, again, our base in this case is negative 3. Our exponent is 4. So we want to take negative 3 times itself 4 times, or negative 3 times negative 3 times negative 3 times negative 3. And let's go ahead and work this out. Negative 3 negatives gives us a positive. Negative 3 times negative 3 here is also 9. And 9 times 9 is 81. So negative 3 to this example. Negative 3 to the fourth. Now the big question is, what is our base? Now notice it looks an awful lot like the example we just did, but I had parentheses, so my base what was ever in the parentheses. Negative 3 was my base. Here, the 4 is only attached to the number 3. So the base here is 3. Okay? So negative 3 to the fourth is negative times 3 to the fourth. Okay? We just learned 3 times 3 times 3 times 3 is 81. So negative 3 to the fourth is equal to negative 81. So let's go ahead and look at these two. Oops. Are not equal. Negative 3, all raised to the fourth power, does not equal this side, which says 3 to the fourth power times a negative. Okay? Very subtle, can be very tricky for students. So make sure you review that example. Let me give you a rule for evaluating exponents. I'll give you 2 rules. First one. Let's let b be any number. That's going to be our base. And we're going to have an exponent of 0. Okay? By definition, a base to the 0 power is defined to be 1. Okay? For example, 10 to the 0 equals 1. Any number raised to the 0 power, by definition, will be 1. All right? Another rule. This rule deals with fractions. Maybe I have a fraction a over b. And maybe I have an exponent n. Okay? A over b to the nth power can be written as a to the n over b to the n. In other words, we can 2/3 cubed. Okay? Notice my a is 2, my b is 3, and my n, or my exponent, is 3 here. Well, according to this rule, I can apply the exponent to the numerator and get 2 to the 3rd over, and I can apply the exponent to the denominator. 2 cubed, well, what is 2 cubed? That's 2 times 2 times 2. And 3 cubed is 3 times 3 times 3. So 2 times 2 times 2, that's 8 27ths. So let me rewrite. So 2/3 cubed is 8 27ths. Okay, so you might want to review these rules a couple times and do